Hi everyone. The lesson is Properties Part 3, Property Attributes under Objective C. So this is Part 3, so you have to make sure that you have to look at Part 2 of this lesson before this. We'll be using these tools and documents for referencing. Prerequisite, as said earlier, you have to refer Part 2 of this lecture before this. You can find the link to download in the description. You will be learning here about property attributes such as read-only, read-write, atomic, non-atomic, etc. As usual, it's going to be practical demonstrations. So let's look at the practical lesson. So this is where we stopped in part 2. So when you run the program written in part 2, basically, okay, so we got a variable here. I'm going to take it off. You don't need it. So the output is this. You will be outputting data of employee, right? Outputting data of employee. And it's doing validations using custom setters. So I will put some other age so that it accepts. So this is what we have done up to now. So in the program we got the properties and we got a custom setter to validate the age. Now we are focusing about property attributes. So let's look at the developer docs. So it says by default read-write property is back. So there are properties called read-only and read-write. So we have done this earlier as well, but I will show it to you. So let's say if we make the property employee number, let's say read-only. So how do you give property attributes? So you'll open brackets, and when you start typing, you will see what attributes are possible. So you got read-write, read-only. You got atomic and non-atomic as property attributes. You got strong and weak property attributes, right? And then you got unsafe, retain likewise, right? So you got copy likewise, right? So let's start with read only, right? So if it's read only employee number, then it means outside classes or methods cannot assign data. So now, because employee number is read only, if I try to set data, I should get an error. So let's compile the program, build. As you can see, it says no visible interface declared set employee number, because the error is technical, but why we are getting this error is because we made the employee number, we made it into a read-only property. Because of that, there will be no setter method getting generated automatically. So because of that, you will not have a setter method. So the opposite of read-only is read-write, right? But you don't have to put it because it's by default read-write. So this will work now, but you really don't need to put it, right? Awesome. So that's about read-only and read-write. Then if we look further down in this developer docs, so if we scroll down, further down, scroll down, then we got into a section called properties are atomic by default. By default, objects properties are atomic. Let's see what this is about. So it says this means the synthesize accessors. So when you say synthesize accessors, those are the getters and setters generated automatically, right? So the synthesize accessors means the generated or getters which are generated automatically, the getters and setters. So the synthesize accessors, this means synthesize accessors ensures that value is always fully retrieved by the getter method or fully set via the setter method, even if the accessors are called simultaneously from different threads. So this is something to do with thread safety. So which means if there are multiple threads running in the program concurrently, the atomic property will make sure that the getter or the setter, the synthesized getter or the setter is executed completely before the value is either changed by another thread or read by another thread. It's always fully retrieved by getter or fully set, even if accesses are called by. So even if multiple threads call, it will make sure that the getter is completed before it allows a setter to set it, or it will always make sure the setter to set it before another thread invoke the getter. So That means the property value will be atomic, meaning it will make sure the property value is thread safe, right? So now it may be a bit hard for you to understand, but just get an overall idea. We'll be talking about this stuff more in detail later, right? So let's read more. And then it says, because of the internal implementation, etc., it's not possible to combine synthesize accessor with an accessor method that you implement yourself. So what that means is what happened to us earlier. So earlier, if you remember, we provided a custom setter, right? Accessor method that you implement. So when I implement, it's a custom setter. Now, then also, for the edge, there is a synthesize getter, right? Synthesize getter. So now, if I remove this and show it to you now, we had to put non-atomic because now by default it's atomic. But now when it's atomic, when I try to provide a custom setter, I'm getting a warning. So that's because this thing, it says it's not possible to combine a synthesize accessor with a accessor method that you implement. So the synthesize, it's not possible to combine this. So synthesize accessor here is the getter, because I got a edge, so there's synthesize getter and a setter. But now I'm implementing a custom setter. So then with the custom setter, there is the automatic synthesize getter. So it's not possible to do that. That's what it says. You will get a compiler warning, right? So you can use non-atomic property to specify synthesize accessors. Now, because you can't do it, you will get a compile warning because of its atomicity, this property. If you want to have this custom setter, you have to avoid that warning, you have to make it non-atomic. But when it's non-atomic, what happens is you can use non-atomic property to specify synthesize accessors simply to set or return the value directly with no guarantees about what happens if the same value is accessed simultaneously from different threads. Which means if you make it non-atomic, there's no guarantee of completion of the accessor method before another thread uses the value. So this is all about to do with thread safety, and if you are not clear of it, don't worry a lot. You will learn more about that in future lessons. So but it's fast because when it's atomic, it blocks it until the thread completes. But when it's non-atomic, it's fast but there's no guarantee of the value not being accessed by multiple threads. So if you want if you are writing a concurrent program with multiple threads, and if you want to guarantee the integrity of the property, you have to make it atomic. That's why it's atomic by default. We'll be talking about this in more detail. So that is the story about atomics and non-atomic. Let's go further down. So you can read more about thread safety and stuff in concurrent programming, right? So let's move further down to see some other attribute properties. So then about strong and weak. So for example, if there's a class, and if you got, say for example, class called XYZ person, and if you create a XYZ person object, right, of that class, XYZ person class, if you create a XYZ object, I'm just giving example, and if that had properties inside that call, say first name and last name, in this case we consider this as this XYZ person object having a strong reference for this string object first name. Then the XYZ person object has a strong reference for this string object last name. So this is called as strong references, and by default it's strong. But if you want, you can create weak references as well. So if you don't want this behavior, so you can make them so sometimes you might need to avoid strong references, like, so that's what it talks here about. And then in that case you can declare it to be as a weak reference, right? But I'm not discussing it in more detail now, because we'll talk about that whenever we need it, when we develop say complex applications. But for now, you know, there is strong and weak referencing as well. So you can read this developer docs for further information if you would like to do it now, right? But you can do it on your own interest. Let's go further down and see about the other properties. Then the section next talks about unsafe, unretained references, right? Let's see what it is very briefly. So once again, I will keep very brief about this. It says there are few classes in Cocoa Touch that doesn't yet support weak references. So now earlier you saw that we can use weak references, strong and weak, but still some classes does not support the weak references, which means you can't declare weak property, right? In those cases, right? So this class includes a NSTextView, NSFont, etc., right? You will see. So if you need to use a weak reference to those classes, then you have to use something called unsafe reference, right? You must use for this property. That means using unsafe, unretained. So this is just in case if there are classes which are not supporting weak references. Once again, I'm not discussing it in detail. For now, we will keep it at this level, right? And let's go to the next property, attribute. Then it talks about copy property, right? Let's see what it is very briefly. So once again here, copy property, it says maintain their own copies. So what does this means? In some circumstance, an object may wish to keep its own copy of any objects that are set for its properties. So what does that mean? So it says as an example, the interface XYZ badge view class. So XYZ badge view, for example, right? If it has two properties, NS strings, then the two NS string properties are declared, both maintain implicit strong references to their objects. Now you know by default they are strong because we discussed earlier about strong property attribute. Consider what happens if another object creates a string to set as one of the badge view's properties. So for example, just imagine you create something called NS mutable string, which is possible, and say create John. Now it's a mutable string, and then if you assign that to the badge view first name, to this one, it's perfectly valid because NS mutable string is a subclass of NS string. So NS mutable string is a child of NS string. So first name is NS string. So you can assign NS mutable string. Now the badge view thinks it's dealing with NS string, right? But it's actually a NS mutable string. It's assigned. Now it means this NS mutable string, name string, can be changed on its own by applying this method. But what happens now is when you change this, it will also change the first name, right? So if you want to avoid this, and if you want to always retain the property value to whatever it's assigned, and then if that, for example, in this case, if that mutable string changes, and still if you want to keep the original value here, then you have to make it a property copy. Otherwise, what happens is by default, when you change name string and append this ny, now initially it's John. So when you assign it here, the first name is John, but after that, when you change this mutable string, because you append ny, it becomes Johnny. So John will change to Johnny. But if you want to keep the original value assigned, which is John or whatever it is, then you have to make it a copy property, right? So that's what this talks here, right? So okay, so I changed the program. I added this code from the developer docs, NS mutable string. So I just made NS mutable string called John. Mutable string means you can change it at any time. So John, and then what I did was I assigned that name string into the property name. Now the property name, event.name, which is the property name, now it's assigned to this, and it's having a strong reference by default of whatever the value, name string. So if you print that here, it prints the name John. So if you run this, it prints the name John. But after that, then this name string, the mutable string, I change by appending ny. Now when I change the NS mutable string, and if I print the property name, now you can see the property name has changed. So this is what happens. But if you don't want this to happen, and if you want whatever the property to have its originally assigned value, and if you don't want it to get changed due to the second reference being changed, then what you have to do is you have to make it you have to put copy attribute. So once you put that copy property for the attribute, and if you run now, see, it's earlier it's John and Johnny, and the same program if I run now, still it maintains its original copy. So it keeps its own copy even though you change the mutable string. So once again, if this is not very clear to you, don't worry, because we'll be using these concepts further, and then we will explain it again in more detail, right? So don't worry about not understanding. If you didn't understand about atomic, non-atomic, or strong, weak, or this, don't worry too much about that, right? Okay, so with that, we have completed the lesson about property attributes. So the most important thing is now you know that there are properties, and into the properties that there are default attributes, but then you can change them by assigning your own attributes such as read, write, atomic, non-atomic, copy, etc. Right? Okay, awesome. So we completed the practical and we got a clear idea to a certain extent about property attributes. If you are not 100% sure about what we discussed, don't worry, we'll be talking about that in more detail in future lessons whenever we use them. We will remind you once again whenever we are using them. So you can find the link to download the source code for the practicals done. We use Apple Developer Docs. Have a look at our other videos about Objective-C. We are very excited to see you in another lesson, and we'll see you in another lesson.